in our home nowadays we use different types of wireless network, wireless nodes like TV control, remote control, AC control, TV remote control or AC remote control. Okay, so from a remote point we can control the functioning of your appliances like television, like camera, maybe computer, maybe AC, maybe anything. So it works on the principle of wireless. Means it sends the signal, send the signal in wireless mode. So no physical connection exists between the controlled device and the person who is going to control it. Okay, so then if we look at this type of structure, so that will be termed as a wireless sensor network. Clear? So now we will discuss about the wireless sensors, means what are the wireless sensors and what are their applications. So what is a wireless sensor network? A wireless sensor network can be defined as a network of devices that can communicate the information gathered from a monitored field through wireless link. As I said, interconnection of different elements is a network, and if information is being collected by any node of this network, it is collected through wireless media. Means there is no physical link exists between the information and the node that is collecting it. So then that will be the wireless. So the short form is WSN. So WSN is a wireless network that consists of, definitely for wireless signal, some thing is required. Means first, a base station that transmits the signal, that receives the signal from many devices, that transmits the signal to many devices after reprocessing it. So it consists of base stations and number of nodes, means connected devices. These nodes are termed as the wireless sensors. These networks are used to monitor physical or environmental conditions like sound, pressure, temperature, and cooperatively pass data through the network to the main location as depicted in this figure. Sure. Now, see, the upper part of this, it is representing the data acquisition networks, means it takes the data. And the lower part, it is representing the data distribution network. Suppose we have a complex network, and in that network we have number of nodes, and each node has some processing capability. It receives some signal. After processing, it is capable to distribute the signal in any form to the users, to other nodes. Okay, so the collection of all the things will be shown in this figure. Okay, so this is what the representation of wireless network. Now you can see this figure. The base station is shown here as mentioned as VST. Okay, so it transmits the radio frequency signal to many devices. And the different these devices, we may call these devices as sensor nodes. They receive the signal, processes it, and further routed the signal to some other node or to end user, depending on the situation. So in fact, this is the representation of wireless network. Now the wireless sensor network is a major area of research in recent years. It consists of compact devices called sensor nodes. These sensor nodes, as I said, are very small, which consist of limited processing and computing resources. Means they are not just dummy. They have some elements, some components by which they can receive the signal, process it according to requirement, and then distribute the signal to some other nearby nodes or to end user. So it has a group of sensors which are used to scan differential environmental conditions to organize and collect the data to some location. Means this is the function of this sensor node. It measures and selects number of physical conditions. For example, means the input, maybe temperature, pressure, humidity, sound, direction, speed, chemical component, vibrations, etc. etc. With the growth in technology, sensor network is executed with small, low power, low cost, multifunctional distributed sensors. Now, if we look at the TV remote control, so how does it function? A TV remote control. Now, see what happens if you look at your remote control. When we press a button, LED glows. That LED emits infrared light. है ना? So on TV or the appliance we want to control, there is some receiver that receives that light, infrared light. And on reception of that, what happens, depending on which type of sensor we are using, it's temperature, capacitor, whatever is the operation, I mean that will change. So suppose its temperature changes, then that temperature we can record with the help of TDR, temperature dependent register. Its resistance changes, then we can read out the resistance, change in the resistance. If capacitor changes, then we can record the change in that. And that change will definitely do some function. For example, if we press one input, so let's say corresponding to a particular channel. So what happens, accordingly, the resistance value will change and the receiver connected to a particular device. In fact, that device tunes the receiver antenna to select a particular frequency. And that particular channel, for example, let's say Sony channel or something else, Sony is what is that? Sony sub and some other channel. That circuit will be tuned to that particular frequency, and the antenna of your circuit will now receive and process the corresponding frequency, and ultimately we will be able to see that particular channel. So this is the simplest working. So in this same fashion, the different types of inputs may be measured, may be sensed by this sensor node. For example, as I discussed, temperature, pressure, humidity, anything. The sensor node can sense, measure, and gather information from different environments, and they can transmit the sense data to the user. So, as I said, the sensor, as I took the example of a TV remote sensor, so it sends the information and then transfer the sense data to the desired point. Okay. Now this the node has capability to perform a given task and are intelligent enough to sense the information, after processing the information, and this passes the information to the end user. So while passing the information, it has many other capabilities. For example, if signal is very small, then some signal power booster may also be used with this sensor node, and it boosts its power, etc., etc. So it is equipped with different types of capabilities, not only sensing the things, processing and converting the processed signal into desired uh, form. Correct. Now, how does it work? So it requires some power. The main power source in a sensor node is battery. Means the power must be stored for its operation. So that's why we need a battery. So the main power source in a sensor node is a battery. Solar cell may also be equipped with this for providing continuous supply to this sensor node. And they may act like a secondary power sources. Okay? So whenever light comes to solar cells, it is converted into electrical power, and this will electrical power will charge the battery. So in this way, we may get continuous supply for working of solar sorry sensor node. A sensor network consists of large number of sensor nodes that are densely located near or inside the occurrence. Means it is present in some at some location. So the number of other nodes may also be present. Okay. The basic components of sensor nodes are power source. Now the basic component means what are the elements of sensor node has. So the primary, or you can say main sources are power source, memory storage devices, processing unit, transceiver. Transceiver means it receives the signals. It has capability to receive the signal, and that signal may be a radio frequency signal, maybe optical signal, maybe some other form. So it has a capability to receive it. And then it also has capability to transmit the signal in same or in some other way. Means the sensor node may receive radio frequency signal and it may be capable to retransmit it in radio frequency or in optical or in any other way. And global positioning systems may also be with this sensor node. So these are the basic components. And these components, they have their own functioning. As you know, a processor, what is the functioning of a processor? It processes the given data to it. So processor perform tasks like processing data and control the functions of other components in the sensor node. So similarly, other components, they have their own functions. Transceiver receives commands from the base station and transmits data to computer or station. I just took an example, computer. It may be any node or base station. It is a combination, means transceiver. Transceiver means transmitter and receiver. So it is a combination of both radio transmitter and radio receiver. So transceiver may be a radio frequency type of transceiver, or optical communication means laser based or infrared type of radio transmitter or receivers. Wireless sensor network consists of two types of sensor nodes. One structured and second unstructured. Structured means the node are placed at particular places. They are not just placed. Some mechanism is also involved beyond placing the nodes. So some optimal number is also selected. Means the placing of nodes is optimal and their number is also what. They are not placed at random. Okay. So that's why they are structured and unstructured. The unstructured is also termed as ad hoc mode. Means ad hoc sensor network. That is called unstructured. The sensor nodes are distributed randomly, means in unstructured, there is no proper distribution of nodes. Okay. But in case of structured, there is pre-planning. Means we have some we have to select some optimal placement of sensor nodes. So the advantage of a structured node is that fewer nodes are deployed with low network maintenance and management cost. So this is true with us as well. If we want to live inside a room in organized way, so we have to manage our day-to-day life easily, efficiently, with low effort, low cost, everything. But if we are living unstructured life, then you can also judge what will happen. Okay, so it is true with us either. So this is the classification, means whether structured wireless sensor network we have or unstructured. Now come to the structure of this, means how they are connected. For a particular task, if we have some wireless sensor network, then how different nodes are connected in this network. So that type of connection is termed as the topology. So wireless sensor networks topologies. So there are three topologies as shown in this figure. One is termed as star topology, second is tree, third is mesh. Now, being a radio communication person, we will discuss the things related to the communication only. So for radio communication network, the structure of wireless sensor network include various topologies like star. Sorry, there is some mistake. Star, tree, and mesh, as shown in this figure. So this is what the star connection. Okay, we have one node that is termed as the gateway. So it receives the signal from the base station and then transmits the signal to the desired node. Okay. Uh, Intermediate nodes may also be present in this network, and that intermediate node is termed as the router node. And these are the end node or users points, you can say. So in the star network, only gateway and end nodes are present. Whereas in tree, the router nodes and mesh router nodes are also present. So they have different the functionality, advantages and disadvantages. So first thing is come to the star topology. So in the case of star topology, it is a communication topology where each node connects directly to a gateway. Means there is a connection between gateway to each node, separate connection. So a single gateway can send or receive messages to several remote nodes. So if a gateway node, it receives messages from base station, it can transmit to all the nodes. And at the same time, it can receive the messages from all the nodes simultaneously. Okay. In star topology, the nodes are not permitted to send messages to each other. So this is limitation, restriction. Means number of nodes may be present in the star topology, but they are not allowed to transmit the messages to other nodes. They can transmit the message to gateway only. So this allows low latency communications between the remote node and gateway, means the base station. Low latency, it is the time taken between if a node transmits some signal to the base station and base station transmits signal to the node. So how much time is taken between these two? So for example, if I make a voice call to you, we will not observe any delay. But if we talk a person that is not in India, he or she is outside of India, and if we give a call to him or her, then we will realize a little bit gap between voices of each other. Have you observed this? So that is called the latency. So in this case, latency definitely will be low because there is no other path. Directly, the node can talk to the gateway and to base station. So the latency in communication definitely will be low. Now, due to its dependency on single node to manage the network, the gateway must be within the radio transmission range of all the individual nodes. And if it is not, then definitely there will not be a wireless connection and communication cannot be possible. The advantage includes the ability to keep the remote node power consumption to a minimum and simply under control. This is the advantage of star topology. Another advantage, the size of network depends on the number of connections made to the hub. So these are few advantages of star topology. Now, the next is the tree topology. Tree topology is also called a cascade star topology. In tree topology, each node connects to a node that is placed higher in the tree and then to the gateway. So if we look at this structure, now here, this node definitely will be connected to a node higher to it, this one, and then to gateway. Similarly, this to this and this to this and then. This node cannot be connected with this here. Okay, so this is the meaning. The main advantage of the tree topology is that the expansion of network can be easily possible and also error detection becomes easy. Means if error take place in any path, then easily we can detect the error. The disadvantage at the other end with this network is that it relies heavily on the bus cable, and if it breaks, all the network will collapse. So this is the biggest disadvantage. This is, and then the last one is the mesh topology. Now, mesh topology allow transmission of data from one node to another node. This type of facility is not available in the tree as well. Means if we want to communicate with this node, direct communication is not possible here. Okay. So this facility is available with only the last type of topology, that is mesh topology. So, and definitely it happens when both nodes are in the radio transmission range of each other. So if a node wants to send a message to another node, which is out of the radio communication range, it needs an intermediate node to forward the message to the desired node. The advantage of one more thing, in case of mesh technology, mesh topology, if we have two nodes, one is A, second is B, and suppose B is not in the transmission range of A, then what will happen? It may take help of another intermediate node and it can transmit the signal to the desired node. The advantage of this mesh topology includes easy isolation and detection of fault in the network. I mean, easily we can detect the fault and we can isolate a particular node if we want. So, but the same time, the disadvantage is that the network is large and requires huge investment. It is a thumb rule. है So if we have more facilities, then definitely sometimes investment may be more.